Good morning, listeners. This is Paul Boyce, President and CEO of PWGC, and this is the Environmental Echo by PW Grosser. Our topic today is going to be marine construction, a very important issue and concept here as we are based on Long Island, and, well, I just said it, it's an island. We're surrounded by water, so there's plenty of opportunities for marine construction, and that can be very diverse and range widely from shore stabilization structures to marine type things for harbors or berthing boats, docks, bulkheads, wharfs, piers, jetties, groins, seawall. I mean, I could go on and on and on, and we probably will this morning. But we'll try to keep it, succinct and to the topic. But it is a pretty important topic for Long Island. I have two terrific guests today. I have Jenny Lund, a project manager and PE at PW Grosser Consulting, and I also have Brian Heflick, and also a PE and project manager at PW Grosser. They're both in our engineering group, and they work not exclusively, but a lot on our marine-type construction projects. I might mention that Jenny's family is in the dock building business and has been for, probably 50 years or so?
50 years.
Over 50 years. So she's got a great knowledge and background in marine and timber construction with those types of facilities. But again, if anyone is interested in the topic, or you have questions, or you want to reach out to us about anything, best way to get a hold of us is through pwgrosser.com/podcast. And again, this is the Environmental Echo. So let's get right into this great subject of marine construction. And I know I mentioned a whole bunch of different types of structures. Most of them are what we call onshore structures. What qualifies as marine construction, guys?
It's a pretty broad category. As you mentioned, you kind of touched on a few of them already, but it's pretty much any structures that are built along the shoreline or within a waterway. You kind of mentioned a few of them already. So common ones are docks or piers, bulkheads, seawalls. You mentioned jetties and also revetments. You can also probably qualify dredging as marine construction, which is you're pretty much excavating material from a harbor or bay bottom, usually to increase the depth of water for navigation, or in a marina if you want to be able to fit larger boats.
Brian, anything you want to add to that?
Sure. You mentioned kind of the larger offshore structures like oil platforms or like wind turbines. We don't do that type of work frequently, but I think there's also undersea cables. I know we have a few jobs like that as far as horizontal directional underwater bodies or through water bodies.
Oh, yeah. So at PW Grosser, right, typical project for us, it's something onshore, or at the shoreline. What do we do? What are we doing these days? What's a common project?
I would say probably bulkheading, and then docks or piers or floating docks for marina. So we'll talk a little bit more about, have a couple projects going out in Sag Harbor, where we just finished a big project which was for a lot of bulkheading. So driving steel sheeting into the ground to create, embankment or
stabilized shoreline.
Yeah, stabilized shoreline. And then also another project where doing some improvements to an existing marina, but then also trying to extend the marina, so adding in additional floating docks and a fixed wave break which will help break apart waves instead of having them kind of crash through the marina and damage any boats or anything that's floating there.
So new construction, renovations, repairs to existing type of facilities, what are we doing primarily?
Sure. So we've also done a few inspections of existing facilities. One was an existing timber pier in a local village. I actually mobilized my kayak to be able to go in and around or under the pier and observe kind of the condition of the fasteners and bolts, as well as the timber structures. And you can assess kind of like what condition it's in, its existing lifetime or remaining lifetime, and recommend if it needs to be replaced and how to replace it.
Oh man, I know we've done piers, we've done wharves, right?
Mm-hmm.
Definitely docks, the bulkheads. It just goes on, and it seems to have really picked up in the last 4 or 5 years. Sort of post Sandy, right? With this type of construction, resiliency, climate change, rising sea levels. How does that impact marine construction? That's a big hot topic lately. Obviously, these structures are right there at the forefront. You know, when you talk about sea level rise, what are we doing about that? How does that impact the way we design these types of structures? Can you tell me a little bit about that?
Sure. So not all marine projects are considered resiliency projects, but a lot are, and they certainly must take into account those forces from the very beginning to be able to have a sustainable design. So yes, you are looking from the very beginning at what the tide cycle is, and during a storm event, how high do you expect waters to get? What type of wave forces are you dealing with? Are those waves carrying debris? And then what type of erosion is going to be happening during this storm? So you have to be able to design your structure from the get-go to be able to withstand all of that. And anticipating what those forces will be is a huge and kind of a difficult operation or design practice. So you do have agencies like NOAA or FEMA that do have published data on storm events that we would design for in certain areas. So you can go on to either like the flood maps that FEMA has, NOAA has weather stations or weather
Brian,
buoys.
do you mind letting our listeners know what NOAA and FEMA stand for, or who those agencies
I
are?
certainly can. NOAA's
All right.
not the guy in the boat.
No.
I'm talking about NOAA, the National Oceanic and Atmospheric Administration.
Yep.
And then FEMA, I am talking about the Federal Emergency Management Agency.
All right. Thank you.
Yes.
Continue. I didn't mean
Yes.
to interrupt,
No, that's fine.
but I did.
So yeah, FEMA hosts flood maps that will you can look up the site area and it'll project onto that map where you would expect to get flood hazards, whether there will be wave action there, when you'd expect a flood, what you would expect the flood height to be during a storm event, and that helps us determine what the height of a bulkhead would be, for instance. We use that for drainage as well. I know Jenny does a lot of drainage work. We also want to make sure that any outfalls that discharge water into a water body, that they have check valves to prevent backflow. That is also a huge issue that could cause flooding in upland areas. And yeah, Jenny.
Yeah, we also use, I think it's the NOAA website that has information on different buoys, which helps provide what the mean low water and like mean high water is. So you can try to design around that, anticipating different elevations of like your tidal cycles. So that helps with, like Brian mentioned, designing some of the aspects of the like check valves. Also, too, shortly after Sandy, they published, forgot who published it, but it was a website that gave you what the actual flood heights were that were found throughout the island. So that also was really helpful when working on trying to design
Is that what
stuff.
we're designing for right now, today?
Right now, the design is usually the base flood elevation plus 2 feet, but it depends on where you are and like what municipality. But that's kind of the standard.
So what dictates the base flood elevation? Is that Superstorm Sandy levels, or is that 500-year storm, or some sort of surge?
So base flood elevation, again, it'll depend on what area you are along the coast, but usually it's the 100-year flood elevation. And then that will be plus the 2 feet. If you are designing, though, like Brian mentioned, the FEMA flood maps have it's a line that's called I think it's the limit of moderate wave action, which kind of shows you where in all of the mapping that has been done, where they anticipate waves to, I guess, what their breaking point is, and when there won't be wave action that can potentially affect or damage a structure. So it'll depend on whether or not you're inside or, I guess, on the seaside or the land side
Yeah.
of that line. So that's another thing. But this usually the base flood elevation is I think it's the 100-year flood elevation.
And is that now changing or continually being updated because of, as I mentioned, maybe potentially climate change or rising sea levels as time progresses? They're predicting, could see by the end of this century another 30 inches in sea level rise or more.
I believe it's the New York State Code and Regulations, specifically New York State. They have a table that is divided up by region and by risk level and by year. So if you want to design a structure that'll be have like a 50-year lifetime, you can look and see how high they expect sea levels to rise in 50 years. So yeah, we do incorporate a lot of that into our designs.
I mean, because it's interesting. I mean, I've seen we do the floating docks. That's real easy. That
Yep.
can go up and down with the tide as need be, right? But you get like a fixed pier. It always just blows my mind that, I'm going to set it this high, and I'm going to have a boat tying up to it, and the tide's going to drop, or the storm's going to come in, and the tide's going to rise. What's going to happen? And people may take that for granted, but we as engineers have to figure out, what's the best elevation to set that platform at, or, how we're going to tie this boat up so we don't have any problems down the road for, the boat owner or the boat itself or other boats in the marina. So this is pretty interesting how you guys, decide this.
Another thing to consider too is you also, when doing design work, have to be cognizant of what's going on in the neighborhood. So for one project that we just worked out in Sag Harbor, we weren't really able to raise the height of the bulkhead that additional couple feet because more towards the town or the more inland, there was existing buildings. So we can't raise the bulkhead 2 feet and then have all the other structures that are nearby at their original elevation, because then you're just kind of creating potentially more damage for those.
Well, I was going to mention edge protection, as far as once you decide to, armor a shoreline or protect your shoreline with a bulkhead or a vetment, that how you end it is very critical, because you may end it, but your neighbor may not have the means to build that structure. And if you end it in a way that's not, well planned or responsible, you could actually inflict more erosion at the end of your bulkhead. So you need kind of like a regional or a neighborhood-wide plan when you do this type of work.
So that leads to a good question then, is who pays for it? If it's a regional thing, is it just the people right there at the shore, or is it, the town, the county, the state? I mean, what are the ideas behind that?
So for residential projects, it certainly is on the, the homeowner or the property owner to take on the financial burden of that. They do have to get their design or their plans permitted by the local agency, so that's when it should be picked up as far as how to responsibly, build this structure so that it wouldn't impact neighbors.
It's never easy, is it?
No.
And I've worked with you in a couple of interesting projects. You mentioned like slope stabilization right down there, bluffs, always major erosion sites, not just from like runoff, but you have groundwater seeps and weeps and everything else. Brian, can you mention a project or two where you've had some experience with some of those really dramatic ones out on maybe the East End or North Shore?
Sure. So you mentioned bluffs. The North Shore of Long Island features gorgeous 60, 50, 100-foot tall bluffs that people have built homes near or around. Those bluffs are constantly retreating due to either natural erosion forces, like, you have rain, you have waves at the bottom, you have gravity, and as they retreat, they eventually retreat towards, a place where someone's living. So those have to be protected.
So we've got these structures up on a bluff, and the slope's eroding to the guy's back door. What does he do, or her, the homeowner? What do they do to prevent their house from falling into the sound or to the ocean or wherever they're situated?
So the best defense for a bluff, and on its face, as in the longest side that is sloped, is to have vegetation on that slope. So if there's no vegetation, one of the most important things is to plant vegetation, something that's native and drought resistant, something that doesn't need irrigation. At the bottom, there's commonly a bulkhead. A bulkhead is a vertical retaining wall that is built right there on the beach.
That could be timber or steel type sheeting, Brian?
Yes.
Okay.
Also vinyl.
Or vinyl. Yep.
Yes. I forget the vinyl.
North Shore commonly has boulders, so sometimes it's a little difficult to install these structures. And then, you have the bulkhead that you want to build to a height that would withstand wave forces, and then you have the bluff face that would slope back from there.
And do you have to terrace that bluff face at all, or how does that work? Is it just the natural angle of repose? What happens?
So the soils have a natural angle of repose, as you mentioned, and that's really what you want to emulate. If you want to do something steeper, you can involve terracing, which would involve constructing kind of like timber boards perpendicular to the face, and you can plant behind those.
Have we ever done any like multiple step bulkheads?
We've done a few. That is a possibility depending on, what access you have to the site and what's available.
Oh man.
And every site's unique, so.
Yeah, I remember there's one that sticks out in my mind is when you brought back some video of a groundwater seep coming out of a face of if it was a bluff, whatever you call it, on the South Fork. And it was, I'm not going to say it was a river flowing out of there, but it was a stream, and the erosion that was going on was substantial.
Yeah, I think you said it looked like a battleship. It hit the bluff.
It really did. It looked like, naval bombardment, unbelievable. And, these are the types of challenges we face living on an island, with that type of terrain. And people do want to live close to the water. That's one of the reasons a lot of us live here. We want to enjoy those scenic and, recreate out there and all that fun stuff. But, man, you got to be prepared for it, huh?
Certainly.
So, guys, would you tell me a little bit? You mentioned vinyl, materials of construction, what's best suited for these types of applications, like the bulkheads, the piers, the wharves. I know seawalls it's going to be rock, but, what type of rock? Is there anything, what are we dealing with? What's our media here?
Sure, I can start with bulkheads since we kind of talked about that a little bit. So the main three materials would be timber, vinyl, or steel. And if you use steel, it's usually going to be an epoxy coated. That way you don't have any corrosion due to salt water.
What about aluminum? I've seen some aluminum sheets.
I think that they have been used on, I wouldn't say smaller projects, but it's not as strong as some of the other materials that I just mentioned.
I've also seen fiberglass reinforced plastic, the FRP.
Yeah, there's a company or two that produce those.
Those look pretty neat.
Yeah, and I think that there are more and more products that are coming on the market now, just trying to be a little bit more innovative. But a lot of, especially like residential structures, will usually be vinyl now because it's really lightweight. It also is. It's able to withstand a lot of force.
So it's strong enough, and it stacks up to steel and timber and all the other good materials?
It's not as strong as steel, but for residential purposes, it's certainly strong enough.
It's also less expensive than steel, which is why a homeowner would prefer to install vinyl as opposed to steel.
It's lighter.
It's lighter,
so,
yes.
Contractor equipment, it's easier to mobilize.
Yeah,
that's a big factor.
Steel's obviously very heavy, and it's also more expensive. I wouldn't say it's twice as expensive to install as compared to vinyl, but it's probably pretty close.
I like the lack of corrosion compared to steel, less chance for marine borers and all that stuff like timber, right? So it's a pretty inert material, but as long as no boats are slamming into it, because I remember we had concerns with our Sag Harbor project when we were looking at it, right?
Definitely. And
somebody bumps into it.
Yeah, and timber, like I said, is not used nearly as much anymore, just to other products that are on the market. I think vinyl, to some degree, kind of replaced that. Installing the timber bulkheads is also a lot more labor intensive, where the vinyl just kind of, it's a sheet that just gets pushed into the ground, and they interlock from one to the next, so they just kind of get installed one after the other. So it's a little bit more seamless.
Are they watertight when they get interlocked?
Yes, they are, and there usually be at the top. There's usually holes that they use to hook onto them to install them.
And the vinyl, that gets driven in like with a vibratory method, just like the steel?
Yep.
Wow. And what's your family using these days? What's its primary material?
They do a lot of vinyl, do a lot of residential work, so a lot of vinyl. So steel less. So like too, I said it's a lot more expensive, so people
are there limits on the vinyl as to how far it can be driven or how deep? I guess it depends on the soil it's going in, but what's the longest vinyl sheet you could get if you had to?
You could probably get it pretty long. I think the limit is the open height or the reveal. So it'll retain maybe like a 10-foot high wall would be good, or maybe even a 15-foot high wall. But once you get higher than that, the bending forces on that material would then lead you to maybe wanting steel.
And we have to tie back the vinyl similar to steel and timber with like deadmen and anchor rods and all that fun stuff?
That's correct, yep.
Oh, geez. All good stuff. Mm-hmm. What about like the rock revetments, or seawalls? Mm-hmm. What are we using, and what type of rock? How heavy does it have to be? What size rocks? I mean, these are all things that people sort of take for granted. They say, I'll just put put it up, you know. Well, I get a 2.5-ton boulder down there. It's not exactly like I can just roll it down the bluff, you know. What's up with that stuff, Brian?
Correct. So one of the benefits of revetments over bulkheads is it can be installed at an angle. So like a 45-degree angle is pretty typical, and that's better at dissipating wave forces without inducing erosion or the loss of the beach in front. So they're very popular now and a pretty good alternative. But as you said, yes, you have to construct them of giant boulders. So you can expect a revetment to require rocks that are about 4+ feet in diameter. Those are very heavy and very expensive to get in place.
I mean, not one of our projects, but probably the most famous, if you want to call it, revetment on the island, Montauk Lighthouse, right?
Mm-hmm.
That's, I believe that's an ongoing project. They just started to redo that. I mean, do you know anything about that project? That's got my interest.
I do know a little bit. I do know the Army Corps is working
Yep.
on it, and I think they have released the plans for it, so you can
But I mean,
see. But yeah,
I'm sure many of our listeners have been out there, maybe you guys, and have walked those rocks, you know, and they're,
Mhm.
they're designed so you can do that. You know,
Mhm.
they're massive.
and
You
yeah,
know?
that's on a very exposed point. So yeah, they need to be to resist the waves that could.
You get
hit
some
there.
huge wave action out there as a surfer. That's one of my favorite spots to surf on the island. You know,
Mhm.
right out there in Turtle Cove, right out in front of the lighthouse, and great place. But yeah, it sees swell from many different angles. You know, all different heights, different sizes, different periods coming in, smacking that thing. I mean, the level of design and attention that has got to be placed into that. You know, you can't take it for granted. But again, people go out and see this nice big rock formation, and they go fishing from it and walk around on it, and you know, all sorts of other things. But its real purpose is to stabilize the tip of the island so that lighthouse stays there for us. You know, which is the main attraction out there.
I agree. Yeah.
So along those lines, you know, we do these interesting projects, but to me, you know, the ones that I've been involved with, it's before we go to actual construction. You know, we get done with doing our design, our due diligence, we figure out what we need to do, and then we got to get this thing approved. You know, it's not like you walk into you know, a retail place and you put your money on the counter and you walk out with a product. This has to get reviewed by, could be several agencies or levels of government. You mentioned the Army Corps of Engineers, you know, Navigable Waters of the United States, you know, that they're always involved. Can you guys describe to me a little bit about the permitting process that's involved with these types of projects?
Sure. I'll start with the Army Corps since you just mentioned that. So that's going to be at the federal level, and they really deal with anything that's being done within navigable waters of the United States. So there's a couple different permits that you might potentially get from them. The most common, I would say, is the nationwide permit, which is they have like a series of general permits that can be issued for minor projects that are fairly standard in completion. So something like a bulkhead or a dock. So it makes it so that a new permit doesn't have to be issued every single time. So the project would just kind of fall under this one general nationwide permit. They also have, I think it's called a letter of permission, where if the project is very minor, if they don't think that there's going to be any objection to it, if it doesn't have the potential to cause a lot of disturbances.
For instance, in Sag Harbor, when we wanted to push the wharf 18 inches
Yep.
seaward.
That was a nationwide permit.
Okay, that's not going to fall under the general. That's more of a
Yeah.
big deal.
Yep. And then there could be another permit, which would be just a specific permit for that project. So if it doesn't fall under one of the other two categories. And then that's at the federal level. Then at the state level, you have the New York State Department of Environmental Conservation, or the DEC, which they have a joint application, which is just like a standard application form that they have that you can file for a number of different permits. So one of them could be either excavation or fill in navigable waters, which would be for like dredging, which we mentioned before. There could be one for, I think it's like docks, moorings, and platforms, which would be if you're doing like a fixed dock or a pier. And then there could also be one for tidal wetlands. So if you're working along the shoreline where there is wetlands and vegetation, you would apply for that permit.
What about, well, you mentioned vegetation. What about the fish? I know we've had some projects where we were limited on when we could be doing in-water work because of either migrating or breeding fish species. How does that impact these types of projects?
It definitely alters the schedule, you could
Oh,
say.
yeah?
So that is a permit condition that we've seen. I think it's come from the Army Corps before, where they limit the time of the year that you can perform in water work. So I think it's the one that we've seen, I think, has been from April 1st through, I think, September, where you can't do any in-water work because they don't want to disturb migrating
So we
fish
couldn't drive
species.
sheets, we couldn't
Correct.
drive piles.
Yep, exactly.
But
So
if as long as we're up out of the water, we can continue to work?
correct. So for the project we're talking about in Sag Harbor, luckily the contractor, we were able to start in September, and the contractor was able to get all their in-water work done by, I think it was pretty much January.
It was cold.
Yeah.
I remember it was very cold.
So they were able to get all the sheeting in time to meet that deadline. But it definitely makes it tough when you're coordinating projects, trying to get permits. You don't know how long it'll take for the permits to come through.
Well,
So
that
you
was
can-
going to be my next
yeah.
question. The typical permitting process, how long does this take? That tends to drive people nuts. Like I said,
Yes.
it's not like you walk up to the window at McDonald's and say, I'll have a Big Mac, and you walk out 10 minutes later. It doesn't happen this way.
No, we've seen as long as 2 years, which is definitely a very long time. But usually it should be somewhere between 6 months and
Jenny,
a year.
just so you know, the Empire State Building was designed and built within a year. That was
Not-
the 1930s, all right? It's a little different now, but you tell me 2 years to get a permit to
Yes.
do a wharf, a pier, a dock, a
Yep.
bulkhead, it blows my mind.
Yeah.
And it's just got to infuriate the owners and the clients that we work for.
Yes, it gets to be very difficult to try to explain sometimes because we're kind of at their mercy we can provide all the information that they need, but depends on where they are in the review process or how many other applications they're reviewing.
Well, that's my follow-up question will be, why? Why does it take 2 years? I mean, obviously they may come back with comments and stuff, but generally sometimes I've seen it's taken 12 months just to get a first review. Are they backlogged, or is it just
Yeah,
there's other priorities, or
I think it's definitely backlog. It could be just not having enough of the technical staff to be doing a review of
so
the
they're
permits.
understaffed? Yeah.
It could be in the one instance where it took us 2 years, they kept changing the project manager that was reviewing it. So every time you'd kind of follow up with them to see where you were in the process, and they would say that it got passed to someone else. So it kind of starts all over again.
And
so
how did our client react? I
Not-
mean, they realize it's not our fault,
Yes.
but they're at the mercy of the
Yeah.
regulatory agency. But they've got if they're a municipality, they've got obligations to the residents and the users of these facilities and structures.
Yeah, it's definitely tough to explain, and obviously we want to do as good of a job as we can for our clients. And we try to obviously do what we can on our end to reach out and follow up, but you can only kind of push some of these agencies so much, especially because they kind of get to it when they get to it. So we just need to make sure that we get things submitted as soon as we can and just follow up and keep our clients updated as to how things are progressing.
Man, it is the red tape and the bureaucracy, it sounds like, with just, like I said, I read fact about the Empire State Building being designed and built within, a single year, which is amazing. Of course, it was the Great Depression, and they were looking for jobs, and there was a whole bunch. But what you can accomplish and what it takes to accomplish this nowadays, it's just. I understand the importance of the environmental and regulatory reviews. This is the environmental echo, so we are environmentally focused. But, and I understand the fish. We have to be cognizant of them. If we can't just disregard and build when we want. But marine construction, what makes it unique compared to other projects we might do in, like, say, the civil or environmental engineering world? Brian, you want to take that one?
Sure. I think waterfront areas are usually a brownfield, so it ties into some of the past podcasts that we've had as far as there might be a lot of history there with past development, particularly on Long Wharf. That site had a lot of past development. There was a berthing facility for whaling ships in the
Oh, yeah.
1700s. Apparently, Thomas Edison tested torpedoes there in World War I, was what we were told.
I didn't know that.
There
Wow.
was, I think the Long Island Railroad had railway lines there, so we dug up railroad ties. Didn't find any environmental issues, just
Thankfully.
debris.
Thankfully.
And there was supposedly a locomotive that either ran off those tracks into the water that we were somewhat expecting to find or hit. So luckily that
So
didn't
we
happen
didn't
either.
drive any steel sheeting through a train, huh?
No, nor a torpedo.
Even more important. Good.
Correct. Or you could have as you mentioned, wetlands, you could have a pristine, untouched environment that you need to protect. And wetlands are very vital to Long Island as they contribute a lot of good functions as far as like filtering out sediment or wave attenuation.
Resiliency. We're
dissipation,
not going
yes.
to beat that topic to death on this subject, but yeah, absolutely. That's our natural buffer. In a lot of these surges and wave effects. So it is important.
Mm-hmm. Besides that, you're dealing in a saltwater environment usually, so corrosion's always a big issue. Any type of component that's made of steel, you kind of have to oversize so that it has some type of sacrificial kind of depth or width to it. Again, you want to expect it to have, let's say, a 50-year lifetime. You have to kind of anticipate how much it's going to corrode over the next 50 years, and will it still be serviceable then?
So like when we coal tar epoxy, say like a piece of steel,
Mm-hmm.
do we have to coat the whole thing, or do we leave it bare below the mud line? How's it work, Brian?
We typically coat whatever side we believe is going to be in contact with water, as well as the length. Once it gets into the mud line, you coat it a little bit, but you don't have to do the full length into the mud line or full length into the soils.
And how far do this is getting into the design, but what's the rule of thumb when you're driving these sheets in? Is it 30% above and 70% in, or the vice versa?
It can typically be 1-to-1. So for every foot you have above the soil, you have 1 foot embedded in the soil.
Oh, geez.
That can improve once you have, you mentioned deadmen before,
Yeah.
or anchors and tiebacks.
Tiebacks.
So you can reduce that with structures like that.
Wow.
I would say one thing too, we were talking about scheduling and potential conditions you might get issued from a regulatory agency. You're also obviously working with the weather and the tides, depending on a project that you're doing. If you're working in like a small bay or harbor, you might only be able to work at high tide, or you might only be able to work at low tide, depending on what you're doing. Especially if you're working on just mobilizing to the site, you would want to be able to get to a site when it's high tide, so you don't get your boat or barge stuck somewhere along the way.
Mm-hmm. That's a great point.
Yep. So that, and also too, just very weather dependent. If it's really windy,
Always is.
Yep. If it's really
Always
windy,
is on the water.
You have to worry about, obviously, if you're say driving pilings, you have this 50-foot long piling that you need to pull up off the deck of a barge, and now this thing's hanging in the air. You don't want it to be gusting at 30
Blowing
miles
around,
an hour
yeah.
and having this thing swinging all over the place. It's just not safe. So just things like that you kind of need to contend with, which can also obviously cause delays to projects during the construction phase. So I think that's something that also makes it a bit more unique than, say, building something on land where that might not be as much of a concern.
I mean, you brought up the tides, and that's like I said, that was a great point, because we've had other projects that weren't necessarily marine construction, but they were down by the water, like we were trying to get water mains in the ground, right? Well, we had to wait for that tide to go out and drop, so the water level went down, so we could put a pipe in. It's just a similar issue you don't think about when you're building these things. What about when you rehabbing structures and maybe sandblasting an old coating off? How do we, ensure that we're not going to make a mess or contaminate the water? Keep things clean, avoid getting the grit, or if it's like a lead-based paint or something that we're taking off. Like I know, like on bridges, which is not really what we're talking about, but we have these, coated steel sheet pilings that the coating starts to really deteriorate, and they oftentimes remove it. What do you do?
So the most foolproof method is probably to install a cofferdam, which is a structure that would be a temporary one, where you would install steel sheeting seaward of what you're trying to clean, and then you can then make that watertight and then dewater the space between. So that way you have kind of an open area to work in. That's obviously the most expensive and rarely done. That you'll see on major bridge projects. You won't see it usually for recoating a bulkhead.
So like in our instance, it was just more cost effective to just go further, like I said, 18 inches seaward in this instance, and drive new sheets and then just backfill it with like stone or soil.
Correct, yeah.
So, and you get the advantage of now having a wider wharf or pier or whatever you're building.
Also, too, depending on what material you're blasting, if you get floatables in the water, you can put out like a boom or a turbidity curtain, which will essentially floats along the water, and you can kind of loop it around where you're working, and that way any material that is floating on the surface will get caught in that, and then you can pull that in and then clean that out to make sure stuff doesn't get too far from the site.
Just to maybe try to bring this thing home a little bit, some projects, right? We've talked about a whole bunch. We definitely talked about our Sag Harbor project, which was one of our bigger marine construction projects. That was like a 600 or 700 foot long existing wharf that really needed a facelift. And one of the aspects I did want to touch on that project in particular was not only was it the marine construction portion, but we also looked to make some improvements to the local water quality. Jenny, can you talk about what we did on that project to improve water quality around the wharf?
Sure. So the existing wharf before we completed the project had all of the water that actually any storm water would sheet off of the parking lot and go into
the deck on the wharf
bay.
was a parking lot.
Yep, exactly. So it was an existing parking lot, so any water would sheet off of the parking lot into the adjacent waterway, which obviously, as you can imagine, if there's a car that's leaking any oil or fuel, that is now entering into that local water body. So
Or any cigarette butts or
exactly,
floatables,
garbage,
anything
yes,
just goes right
exactly.
off. Huh?
So what we did in the design is we raised the elevation of the perimeter of the site and turned it so that all the water drained to the center of the site. And we installed some catch basins and some drainage piping and 2 stormwater treatment units that would remove things such as trash, debris, sediment, and also any hydrocarbons. And from that unit, the water would get treated and then would discharge out into the bay.
Now, those units need periodic maintenance, right? It's not
Yep.
set it and forget it.
Nope, you have to maintain. You have to at least look into them every 6 months. So you just open up the cover, similar to a manhole cover, and you just kind of look in to see if any sediment or debris has been collected. Once it starts to fill up, you'd get like a vacuum truck that would come and suck any of that debris out, and then you can close it back up and then inspect it again in 6 months. So usually in the spring is a good time to inspect it, mostly from in the winter when there's like all the sanding and salting operations.
Okay.
You might get some of that gets collected.
Part of the permitting of that project, we had to get a letter from the village to be sent to, I believe, was it the Army Corps or the DEC?
I think it was the DEC.
That committed to maintaining those systems. So,
Aha.
so to get those permitted, you have to
I'm
basically
sure the
commit to doing
village
a
is
maintenance.
inspecting them regularly.
Yes.
And we will follow up. So what other projects? What were some of the more notable marine constructions at PWGC that we've done in, say, the past, 5-6 years?
The local, I guess, Port Jeff
Yeah, that was
Harborfront
pretty cool.
Pier inspection that I did via kayak. That resulted in a repair effort. We made a whole bunch of recommendations.
That one was interesting because they were noticing some sway on the pier when they were holding like events and stuff like that, if I'm not mistaken, correct?
Right. So they initially called us because I believe they had 300 people, an estimated 300 people on that pier, all on one side, and people reported that it started to move a little bit. So that's what they called us and asked us to take a look at it. The major improvement we made was replacing all of the cross braces that help prevent such swaying,
Yeah.
as well as recommendations on installing new ones in different directions. Also found a few, pretty corroded fasteners and bolts that
I remember, yes. You showed me some good
Some are worn
section
through.
loss on some of those things, which
Yeah.
was getting close.
Yeah. But yeah, that was definitely a fun, notable one. I believe that pier is around 100 years old, so I also did research to see, how long you would expect a pile to last and if any should be replaced. Turns out they last a pretty long time.
How long?
I believe I had to look up some research from like the Netherlands. It said, you can expect like 150 years for some of this.
On a timber pile.
Yeah.
Wow.
So they had records dating back to, I guess, 150-year-old piles that apparently still had a measurable service lifetime. So
Cool.
we used that to in our report and our recommendations.
What about some of the floating dock work? Again, we've done some of that stuff out in Sag Harbor
Yep.
also.
Yes, we're working on a project now in Sag Harbor where there's an existing transient marina, so we're proposing to replace all those floating docks and move some pilings around to be able to make some of the finger piers where boats dock next to a little bit longer, just to a little bit better serviceability for those that are visiting. And then also put an extension on for 8 additional slips for, I think, boats up to 60 feet long. So that would be pilings
pretty
and
good-sized boat.
floating docks. And then I mentioned before a fixed wave break to help kind of break apart any waves before they come through the marina.
Smash someone's boat up?
Yep, exactly.
So it's like with a floating dock, right? What gives it its buoyancy, Jenny?
They're usually like plastic drums, basically. So they can be, I think, standard sizes, say like a 4x4, 4x8, and it's just kind of almost looks like a plastic container. It's usually filled with foam, and that's what gives it its buoyancy.
I was going to say, you want to get something in there to keep the water out in case you do get a leak.
Yep, and
So
then
foam's a good idea.
Yeah, and then you build the dock on top of that, which is usually made out of timber.
Timber.
Yep.
Oh, interesting. This has been really informative, guys. You guys have any closing thoughts or ideas you want to share on marine construction before we wrap it up for the day?
No, I think I'm good. This is great.
Also good on this
Brian,
end.
oh man, you guys, well, you did cover the topic very thoroughly, and we are engaged in quite a bit of this work at PW Grosser. I do want to thank the both of you for coming in today. Hopefully our listeners found this informative and educational. It's, again, our guests today were Jenny Lund, a project manager and professional engineer in the engineering group at PW Grosser, and Brian Heflick, also professional engineer and project manager in the same group. And I am Paul Boyce, President and CEO, your host of the Environmental Echo. That is the PWGC podcast. And again, if you have further questions on this topic or any other topics we've covered in the past, you can feel free to reach out to us via pwgrosser.com/podcast. And again, this is the Environmental Echo, and I thank you all for listening today.